So welcome everybody. Thank you for your participation. I'm excited to share my knowledge and insights about blockchain. Blockchain is not an easy subject and is also difficult for many to follow. On a daily basis, I'm involved with the development, not the technical developments, but the business side of things. And it's also especially with the monetary aspect. And it's taken years to understand its politics, the monetary policy, privacy, security, and the possibilities of it. So I'm still learning every day. I'm going to show you at a high level and explain what blockchain is and how it works under the hood. Keep in mind that some of the visualizations are simplified to make it more sensible and understandable. My colleague Menno will explain the technical side of things of the blockchain, and he will dive into the code with you guys. So without further ado, let's dive into it. So where am I? I'm Derin Karim, 28 years old. I'm an IT consultant at Capgemini. I was born in Kurdistan. I studied business IT and management. I worked in the IT branch since 2012 for various roles, the business development and project director of various blockchain projects. In particular, one of them was like a decentralized cloud environment. You can compare it with a decentralized AWS. So I've always had this passion for technology when it comes to tech and blockchain or AI or machine learning, whatever it is. So I love keeping shape and play soccer. Also, I love reading about monetary economics, monetary history, and I'm an investor myself. So that's me in a nutshell, and let's see what the program of tonight is all about. So I will talk about what blockchain is. So in my examples, I will mainly talk about the Bitcoin blockchain technology. We are going to talk about how it works and show you some use cases of some blockchain technology. So I always say the potential is comparable actually with the internet. The internet made information openly accessible, and people from all over the world can communicate with each other, right? So the internet is a revolution in access to information. Blockchain is a revolution in trust. With blockchain, you can make transactions possible between people who don't know each other or nor they trust each other, without the need actually for a central party or an intermediary or a middleman. So this technology is so actually powerful that it can transform the very basic pillars of our society. A technology which is actually fundamentally influences the way that our economy, governance systems, and business functions, and change our conceptual understanding of trade, ownership, and trust. So what is a blockchain actually? A blockchain is often compared to a ledger. So as you guys might know, a ledger is an accounting concept and contains all of the income and expenses of a company. You can think of a blockchain as a digital ledger in which transactions are recorded. This ledger contains all the transactions that have ever been made. All kinds of transactions can be recorded in the general ledger. In one case, it's a payment with like a digital currency, like the Bitcoin, or in the other case, to exchange important data between two parties, such as contracts, certificates, or titles of ownerships. They have one thing in common, though. They become blocks of information that are digitally signed by both parties, but without the intervention of a third party. So people think of Bitcoin as only a virtual money or transaction system, but if you really look closer, you will see that the monetary aspect is just a tip of the iceberg. That's because Bitcoin is a groundbreaking internet technology from my point of view, for which money is merely one of the possible applications. So money exists to trade, to facilitate trade, right? Trade has become complex over the centuries. Everybody trades with everybody, and that is all being recorded in bookkeepings. So this information is often isolated and close to the public. For this reason, we can use third parties and middlemen to trust to facilitate and prove our transactions. So think about governments, banks, accountants, notaries, and the paper in your and paper money in your wallet. We also call this trusted third parties. And this brings us to the essence of blockchain technology. So the blockchain enables a network of computers to keep joint accounts via the internet. These accounts are not privately or owned by one party, but are contained in one public digital ledger that is fully distributed over the whole network. The blockchain contains all the transactions which associate dates, times, and also their owners, also including their balances. So every node in the network owns a full copy of the blockchain. So you can think of it as a large digital public ledger. So every transaction is public, and many thousands of nodes agree that the transaction has taken place undisputed. You can think of it, it's like a notary between every transaction to stamp and verify the transaction. So here we have an overview about the centralized and decentralized and the distributed overview. So as we know, most databases and ledgers are centrally organized. That means that there is one location where all the data is stored. Only in that place, the data will be added, changed, or deleted. So there might be a single point of failure. But blockchains come into their own when organized differently, like centralized, decentralized, or distributed. There is no central point there's no central point actually, but there are several nodes that are contained as a copy of the database or general ledger. So all those nodes together, we call it the blockchain network. So these nodes perform work for the network itself. So think of listening to the new transaction and collecting them into one block. Calculate the correct signature for the block, or make the block known to the network, so broadcasting the blockchains to the nodes. So in fact, the fact that the blockchain is distributed across multiple nodes makes it even less susceptible to fraud. So we all looked into that in just a bit. But what is a blockchain, right? So how do they work? What problems do they solve? And how can they be used? Like the name already indicates, the blockchain is a chain of blocks that contains information. So this technique was originally described in 1991 by a group of researchers and was originally intended to timestamp digital documents, so that's not possible to backdate them or to tamper with them. You can think of it as a notary. However, it went by mostly unused until it was adapted by Satoshi Nakamoto in 2009 to create the digital cryptocurrency called Bitcoin. And I think most of you guys are familiar with the Bitcoin who's watching this. So his goal was to create a monetary asset which wasn't controlled by any government. And its philosophy was based on libertarian Austrian economics. So one of the famous quotes you see over here is like, with e-currency based on cryptographic proof, without the need to trust a third-party middleman, money can be secure and transactions effortless. So it's a total new mindset and digital asset which came into existence. So let's see how a blockchain works. So a blockchain is what we already mentioned, a distributed ledger that's completely open to anyone. They have an interesting property though. Once some data has been recorded inside a blockchain, it becomes very, very difficult to change it. So how does that work? Well, let's see. So each block contains some data, the hash, and the hash of the previous block. Let's zoom into the data. The data that is stored inside a block depends on the type of blockchain. The Bitcoin blockchain, for example, stores the details about the transaction in here, like such as the sender, the receiver, and the amounts of coins which is sent. That's very basic overview about the Bitcoin blockchain. A block has also a hash, which we said. So you can compare it as a fingerprint. It identifies a block and all of its contents, and it's always unique, just like a fingerprint. Once a block is created, its hash is being calculated. Changing something inside the block will cause the hash to change as well. So in other words, hashes are very useful when it comes to detecting changes to the block. If the fingerprints of the block changes, it's no longer the same block. And the last element is each block has a hash of the previous block. So this effectively creates a chain of blocks, and it's unique that makes its blockchain so secure. Let's go into example. Here we have a chain of 3 blocks. As you can see, each block has a hash of the previous block. So number 3 points to the number 2, and number 2 points to number 1. Now, the first block is a bit special. Pointing to the previous block, because it's the first one, it's not possible. So we call it the Genesis block. That is broadcasted openly into the network. I'm not going to dive into the Genesis block, but it's openly and it's not relevant to the hashing of previous blocks. Now let's say that you tamper with the second block, right? This causes the hash of the block to change as well. In turn, that will make block 3 and the following blocks invalid because they are no longer store the valid hash of the previous block. So changing a single block will make the following blocks invalid. But using hashes is not actually enough to tampering, to prevent actually tampering. Computers these days are very fast, as you guys know, and can calculate hundreds of thousands of hashes per second. You can effectively tamper with a block and recalculate all the hashes of the other blocks to make your block valid again. So to mitigate this, blockchains have something called proof of work. It's a mechanism that slows down the creation of new blocks. In Bitcoin's case, it takes around 10 minutes to calculate the required proof of work and add a new block to the chain. This mechanism is very hard to tamper with. And because if you tamper with one block, you need to recalculate the proof of work for all the following blocks. So the security of a blockchain comes from its creative use of hashing and the proof of work mechanism. But there's one more way that blockchain secures themselves, and that's by being distributed, what we talked about already. Instead of using central identity to manage the chain, blockchain use a peer-to-peer network, and actually anyone in the network is allowed to join. So when someone joins this network, he gets the full copy of the blockchain. The node can use this to verify that everything is still in order. Now, let's see what happens when someone creates a new block. That block is sent to everyone on the network. Each node then verifies the block to make sure that it hasn't been tampered with. And if everything checks out, every node adds this block to their own blockchain. So all the nodes in this network creates consensus. They agree about what blocks are valid and which aren't. So blocks are tampered with will be rejected by other nodes in a network. So to successfully tamper with the blockchain, you will need to tamper with the blockchain itself, redo the proof of stake for each block, and take control even also for more than 50% of the peer-to-peer network. Only then will your tampered block become accepted by everyone else. It's actually impossible to do so. So in the past slides, you have seen the most important aspect of a blockchain. So mainly the Bitcoin blockchain, but there are also several generations of blockchain. For example, we talked about the Bitcoin as the first generation. Ethereum, as you guys know, is a second generation, and IOTA, Neo can be said as a third generation. So, and the fourth generation is now under development. Think about oracles like Chainlink. So blockchains are constantly evolving as well. One of the more recent developments is the creation of smart contracts. So this came into existence when in 2016 the Ethereum blockchain came actually in a market or public to anyone. So these contracts, these smart contracts, are simple programs that are stored on the blockchain and can be used automatically to exchange coins based on certain conditions. So Menno will zoom more into the details of smart contract in just a bit, but the possibilities are very, very promising. But let's look beyond cryptocurrencies. Let's see what kind of use cases these kind of blockchains are useful for. As shown here, there are many use cases for blockchain technology. Think about money we talked about. We will talk about something about real estate and healthcare. Some of them are a no-brainer, like supply chain, and already used by some of the companies, while some of them are still under development and close to a real-life use case. Now, let's look how blockchain technology can be used by cars, for example. You probably ever heard of the odometer fraud, right? So by tampering with the odometer, someone can make a car appear to be newer and less worn out, resulting in customers paying more than what the car is actually worth. The government tries to counter this by collecting the mileage of the car when they get a safety inspection, but actually that isn't enough. So instead, we could replace regular odometers with smart ones that are connected to the internet and frequently write the car's mileage to the blockchain. So this will create a secure digital certificate for each car. And because we use blockchain, no one can tamper with the data and everyone can look up the vehicle's history. In fact, this is already being used and developed by Bosch IoT Lab, and they are currently testing on a fleet of 100 cars in Germany and Switzerland. So we know that blockchains are great at keeping track of things over time, but besides odometers, you can also track of things like intellectual property, patents, and even functions like a notary. Let's zoom in about that. See, a notary is someone who can confirm and verify signatures on the legal documents, but we can just as well use the blockchain for it. The online website stamp.io, for instance, allows you and me to add documents to the Bitcoin or Ethereum blockchain. So once added, you can always prove that you created a document at a certain point in time, much like a notary. Although right now blockchains aren't on the same level as a notary in a legal perspective. So another interesting application is digital voting. Right now, voting, as you guys know, appears either on paper or special computers that are running proprietary software. Voting on paper costs a lot of money, and electronic voting has some security issues as well. So in the recent years, there have been countries move away from the digital voting and adopting paper again because they fear that electronic votes can be tampered with and influenced by hackers. But instead of paper, we can use also the blockchain to cast and store votes. Such a system will be very transparent, as everyone could verify the voting count for themselves, and it will make tampering with the blockchain very, very difficult. So the Swiss company Agora, I think, Agora is already working on such a system and is going to be completely open source. But there are many challenges, to be honest. So first, you have to be able to identify voters without compromising their privacy. Secondly, if you are allowing people to vote with their own computers or phone, you have to take into account that those might be infected with malware designed to tamper with the voting process. So definitely an interesting use case of voting on a blockchain, but it becomes reality. But when it becomes reality for a more transparent and practical voting system, that will be very interesting as well. I think Donald Trump will be a very man as well. So we don't get the situation about the election of of last November. So let's move to yet another example, the food industry. They could use blockchain technology to track their food products from the moment they are harvested or made to where they end up with, like in the hands of customers. See, every year, almost 500,000 people die because of foodborne disease. And that's particularly because it takes too long to isolate the food that is causing harm. So blockchains could help to us to create a digital certificate for each piece of food, providing where it came from and where it has been. So if a contamination is detected, we can track and trace it back to the roots and instantly notify other people who bought the same bad food. Walmart and IBM are currently working on such a system. It allows them to trace the origin of a box of mangoes in 2 seconds. Now, just compared to days or weeks in a traditional system, that's actually mind-blowing. A system like this could also be applied to other industries as well. We could use it to track regular products and battle counterfeit goods by allowing anyone to verify whenever a product comes from a manufacturer they think it does. Think about high quality or luxury brands, which are very counterfeit goods, which is used in third countries. So another idea would be to track packages and shipments by using blockchain. That is something that IBM and container ships giant Maersk are already working on. So a decentralized ledger to help with making global trades of goods very efficient. So far, actually, we looked at ways how blockchain can be used to track information and verify its integrity. But blockchain can be even more powerful when we add smart contracts into them, that we already talked about. So these smart contracts are tiny computers that live on the blockchain and can perform actions whenever like certain conditions are met. So insurance companies could use smart contracts to validate claims and calculate a payout. Or they can allow us to pay for car insurance when we are driving. But it goes even further. So with smart contracts, we can secure our own data on the blockchain, which is very important. They could, for instance, allow us to store our medical records on the blockchain and only allow the doctors to access them when we approve it with a digital signature. In the same fashion, you could store your personal identity on there and choose what data do you want to reveal. So think about ordering alcohol in a bar, for instance, only that requires you to prove that you are over the legal drinking age, and with a smart contract, you can deliver that proof without revealing actually anything else. So as you can see, blockchain technology can be used in very different ways. This is just a brief overview on how they could be used, and by no means a complete list of all the applications. Every day, developers are working hard on various innovative technologies and applications on the blockchains. Some will fail, and some already have partnerships with major enterprises. So myself, I'm very confident that it won't take very long. We actually see some of these use cases in mass adoption, like the voting system. I'm very a big fan of it. My colleague Manu will go deeper into the topic of smart contract with you guys in a fun and interesting way, where he's already working on in real life. So thank you for your attention, and I hope you have been able to make the subject blockchain more accessible at a higher level.
Okay, Derin, thank you for your presentation.
Thank you.
I can see we have 2 recent questions from our audience, both from Erik Stur. Let me start with this first question. Sometimes one hears, perhaps unfounded, news about criminals having better possibilities to launder money using blockchain because it's more difficult to follow the money. What do you think?
Actually, I don't fully agree with that, but because on the blockchain you can really follow the money. The hard thing is to associate a certain address with a real life person. So you really can see, and it's transparent, the blockchain, where the money is and where it's going. So following the money is quite easy. It's preventing the money to be spending. That's the hard part.
Exactly. And if I would be a criminal, I probably would use a blockchain like Monero or something like that.
Absolutely, like privacy coins, right?
Exactly. Okay, another cool question. Could blockchain technology also be used in chains of news to verify that news is not tampered with, for example, and to perhaps enable proper validation of the first legitimate source?
Absolutely. I know, man, I forgot the name of this project, but they are already working on such a system, because it's this fake news or deep fake thing or whatever it is. It's a huge thing, a huge issue in the America. So they're already working on it, and yes, Eric, they really can work on such a system to prevent that.
Okay, there's another question popping in right now. In a mining process, there is said to be a process in which mathematical problems are being solved, which the difficulty increases over time. What kind of problems are actually being solved here? It's a very technical question, Derin.
So they need to solve like a puzzle, a very hard mathematical puzzle, which is getting harder and harder if the hash rate increases. And yeah, it's very hard to explain the mining process actually, but it comes up to like there's a mathematical puzzle which you need computing power for it to solve it, and it's a really random generated puzzle. So I hope that answered your question. Else you might want to look up at the mining process of blockchain technology, which explains a lot.
Okay. Also, let's discuss the final question of Johan. Looking into the economics of Bitcoin, is it theoretically possible for anyone to increase the total supply of 21 million Bitcoin? If yes, how?
They could. So what I said, it's open source. It's open to anyone. So they could increase the supply rate of 21 million. But here's the thing. No one, like all the nodes, they won't agree that that's the proper Bitcoin core version. So you can copy the Bitcoin blockchain, but you don't have any nodes to validate your blockchain. So you don't participate with the 21 million version. Maybe you want to look up Bitcoin Cash, which already did some similar thing with the block size.
Okay, then a final question from me, Derin. Let's talk about money. That's always fun, I guess. What do you think the Bitcoin price will be by the end of this year, or let's say by the end of 21?
So first of all, I'm not a financial advisor, so I don't give any financial advice. So I'm a big believer in digital scarcity, especially when it comes to the Bitcoin application and the monetary policy. Again, it's just a thought. So don't invest your money in something which might be worth nothing. So I think it can be worth at least 100K by the end of 2021.
Okay, interesting.
Yeah, it's very interesting. Yeah,
okay,
I'm still in the game, so yeah.
I want to thank you for your presentation. Yeah, and we're going to continue with our program.
Thank you, Martin.
Thank you.
It was a pleasure. Thank you.
Okay, good night.